So in section 2.4, we talked about equations of parallel lines, right? Parallel lines have the same slope. Here we're talking about equations of perpendicular lines. Now, perpendicular lines have opposite reciprocal slopes, right? So we know that opposite means we're changing the sign, right? So if it's positive, it would be negative and vice versa. And then a reciprocal is just taking that number as a fraction and flipping the numerator and the denominator, all right? Now you'll see this symbol is like an upside down capital T. That upside down capital T symbol means perpendicular, all right? So whenever you see that, think perpendicular. Here we can see that the red line and the black line are perpendicular because they have opposite reciprocal slopes, right? So this would be a right angle there. Those are perpendicular. Notice the red line has a slope of 2. The black line has a slope of -1/2. So notice the positive 2 becomes a negative, and the 2, which is like 2 over 1, becomes 1 over 2 when we take the reciprocal. So those are perpendicular lines because they have opposite reciprocal slopes. So in this first example, are these lines perpendicular? Well, we know that the first line has a slope of 3. So if I rearrange this in slope-intercept form, we're going to subtract 2x on both sides. That leaves me with -6y equals -2x plus 18. And then we're going to go ahead and we're going to divide everything by -6. And we end up with y equals, when we reduce 6, we get positive 1/3 x, and then 18 divided by 6 is -3. So if I look at this slope here, well, we can see that it's 1/3. So the question is, are 1/3 and 3 opposite reciprocals? Well, they're reciprocals, right? Because 3 over 1 becomes 1 over 3, but they're not opposite, right? 3 would need to become a -1/3. So because it's not opposite, the answer is going to be no. These would not be parallel to each other. Sorry, perpendicular to each other. You could go ahead and graph these on Desmos or on your calculator, and you would find that there's not a right angle formed between these two lines. Answer is no. Next, write the equation of a line that goes through 6, -5 and is perpendicular to this line. So this might look familiar. This is similar to the problem we did on the previous 2.4 homework. We're going to subtract 2x on both sides, leaving me with -y equals -2x plus 7. I'm then going to divide everything by -1, which changes the signs of everything. And so we know that the slope of this line is positive 2. So if I know that the slope of this line is positive 2, I know that the slope of my new line has to be -1/2, right? Opposite reciprocal slope. And then it has to go through 6, -5, right? And we know the x and y values there. So given my new y equals mx plus b, we know that the y value is -5, the x value is 6, and my slope is -1/2. That gives me -5 equals -1/2 times 6 plus the y-intercept b. I can then start to simplify, so -5 equals -3 plus b, because half of 6 is 3 and it's negative. Then if I add 3 to both sides, we get -2 equals b. So now that I know the slope of my new line, that's perpendicular, and I know the y-intercept of my new line, I can go ahead and write my final answer, y equals -1/2 x minus 2. All right, and that's going to be your final answer. Again, notice how my slope is the opposite reciprocal from the 2, right? So it has to be perpendicular. Last one here, write the equation of a line that passes through the point -1, 3 and is perpendicular to the line that goes through these 2 points. So again, I can start by finding the slope, x1, y1, x2, y2, for these 2 points here. So if I subtract the y values, 10 minus 8 on top, and on the bottom we subtract the x values, so x2 minus x1. This gives me 2 over -1, which is -2. So the slope between these 2 points is -2. But again, I want a line that is perpendicular. So I want the opposite of 2, which is positive, and I want the reciprocal, which is positive 1/2 in this case, all right? So my slope is 1/2, and we want it to go through the line -1, 3. All right, that's where we want it to go through. So again, I'm going to start with y equals mx plus b. I'm going to go ahead and plug in 3 for my y value. I'm going to plug in 1/2 for the slope. I'm going to plug in -1 for the x value. And I don't know what the y value is just yet. Here we've got 3 equals -1/2 plus b. And when I add 1/2 to both sides, we get 3.5 equals the y-intercept. So all together, we've got y equals 1/2 x, right? My new slope was 1/2. And we just found out that the new y-intercept is 3.5. So plus 3.5. Or you could write plus 3.5 if you want. That's also the same thing. So there you go. That's your answer. So again, if you went on Desmos and you graphed these 3 points and you graphed this line, you'd be able to see that this line is perpendicular to the line that goes through these 2 points, right? Because again, look at the slopes, 1/2 compared to -2. Those are opposite reciprocals, so they're perpendicular. And then it will go through this point because we just found the equation, right? We plugged in these values and found that equation, all right? So that's how you work with perpendicular lines. Very similar to how you work with parallel lines, just have to remember that perpendicular lines have opposite